Hi, my name is Iron. I am a master's student at Federal Institute of Goiás in Brazil. Today I'm going to present a poster of an article entitled Synthetic Series of Electricity Generation through a Photovoltaic System by using different panel temperature models. This work is part of my master's research and compares three temperature models of photovoltaic panels and electricity produced from a photovoltaic system located in the Midwest region of Brazil through the evaluation of expected errors and standard deviations. The results indicate, through a stochastic analysis, the model that best describes the physical system in relation to photovoltaic technology, location, and measurement values. Photovoltaic solar energy is the fastest growing energy source in the world. The electrical energy supplied by photovoltaic panel is a function of the solar irradiance and the model temperature. There is great difficulty in predicting the energy generated by photovoltaic systems. Panel temperature and power output depend on several stochastic factors such as solar irradiance, ambient temperature, wind speed, humidity, and wind direction. Panel temperature can be predicted by several models. This work compares the performance of the models presented by Masters, Neto, and Talismani from a stochastic perspective. This study aims to fill the gap in the small number of studies that consider the random variables to estimate the electricity generated from photovoltaic systems during the project lifetime. The flowchart of the methodology used in this work is shown in Figure 1. We enter with the historical data, then we obtain the stochastic model for each random variable from the pre-processing and validation of the models. We then generate the synthetic series of random variables that will predict these variables throughout the life of the project. We then use the synthetic series of the random variables to estimate the panel temperature using the different panel temperature models. Then, from the data from the photovoltaic system, we calculate the power and energy generation of the photovoltaic system. Here we have the autoregressive stochastic model to describe the random variables. Data preprocessing is performed by pulling out the trends. Model validation is done using the mean relative percentage error. Here we have the panel temperature model's equations, and here we have the power generation model. Historical data of solar irradiance, ambient temperature, wind speed, humidity, and wind direction was obtained from the National Solar Radiation Database for a photovoltaic system installed at Itumbiara IFG campus. In Table 1, we have input data from the photovoltaic system. Table 2 presents the estimated parameters of the AR model for each variable. AR parameters were estimated using the maximum likelihood method. It was generated 2,000 scenarios of the synthetic series of the random variables for the entire period of the historical data, which was 20 years. Then, historical series and synthetic series were compared with each other in relation to their average, standard deviations, minimum, maximum, and the mean relative percentage error. In Figure 2 and 3, we have the validation of the synthetic series with the average of the historical data. Table 3 presents the statistical parameters of the synthetic series for each variable. Figure 4 presents the measured and calculated temperature of the panels using the different temperature panel models. The values of panel temperature measurements were obtained from January 17, 2018 to April 16, 2019, corresponding to 16 months. The mean percentage error from panel temperature calculated using models A, B, and C with the measured panel temperature are 5.73%, 4.67%, and 3.77%, respectively. as we can see here. Figure 5 and 6 present the monthly and annual average and standard deviations of the energy generated for each temperature model. The decrease in generated energy found in Figure 6 is due to the degradation of the panel's efficiency over time. We Conclusion: we used the autoregressive model to predict the random variables solar irradiance, ambient temperature, wind speed, relative humidity, and wind direction over the project lifetime. We then used the prediction series to estimate panel temperature and power generation using the different panel temperature models. Panel temperature measurements were also performed in a photovoltaic system located in the city of Itumbiara, in the Midwest region of Brazil. The results indicated that the model that came closest to the measurement data was Model C. This work aimed to analyze the panel temperature models from a more precise perspective and can be used in risk studies, as in the economic feasibility analysis of photovoltaic systems. These here are the references used in this poster, and thank you.